Okay, so sorry. For the first thing we want to know is that graphs have edges, vertices, and edge weights. And so these would be the edges, these would be the vertices, and these are edge weights. The next thing we want to note is that trees are graphs that are acyclic, and this implies that their absolute value of the amount of, the amount of vertices minus one would be equal to the amount of edges. So in this case, this would not be acyclic because we have this loop here. So this would not be considered a tree. Cool. So the next thing we want to talk about is depth first search and breadth first search. And so the way we would go about doing this is if we were writing it in code, we would use a stack and we would traverse unvisited vertices as far as possible, break ties alphabetically, and like usually this would be specified in the problem. Sometimes in numbers, you use lowest number. If there's ever, you can usually clarify this type of information during a test, how to break ties. And then the last part about depth first search and breadth first search is we actually would not utilize edge weights, as we'll see in later problems like Dijkstra's or A-star search. Edge weights will be really important to us, but in case of depth first search and breadth first search, we don't care about edge weights. So the next thing we have is breadth first search over here. And so we want to use a queue. We'd also traverse unvisited vertices based on the number of edges from start vertex. And I'll make this a little bit more clear in the problem, but basically when it says traverse unvisited vertices based on number of edges from start vertex, it goes like this. So we'd go A because, we go to B because B is one away. And then we'd also go to C because C is one away. And then again, we're going to break ties alphabetically, but this can vary problem to problem. It's important to specify. And then we're going to ignore edge weights. So yeah, that may be a little bit confusing at first. And so let's just kind of like hop into a problem. And I guess we can go over depth first search, how this will work. So we'd start at A, and then we'd go, because break ties alphabetically, we go down to B. We continue trying to go, so we go down to D. Again, we'd break ties alphabetically, so we go to E. We say, okay, we're stuck at E, so we go back to our previously visited node, which would be D. We see if we can go anywhere from D. We can go to F, so we go to F. From F, we would go to C, and then we would be done traversing. And let's do a similar one for breadth first search. We start at A, we go to B because B is one away. We look for anything else one away. We see C is one away, so we go to C. D is two away, so we go A, B, D. And then we go back to we would go back to C. We would go to F, and then lastly we'd traverse E because that's the farthest away.